In this video, we're going to talk about inverse functions. This really was an assignment, a worksheet that you needed to take home and fill out with your book, Algebra 2, McDougall-Littell, page 422, um, for my honors kids. For my on-level students, we were doing this in class, but this is for Adam, because he's the one that encouraged me to make this video. No, he held me to it. All right, so if we're looking at this, in the notes, in the textbook you would read, how do you find the inverse of a relation? Well, in the textbook it explains that the inverse of a relation is found by switching the x and the y values. So let's state the domain and the range of this function. So domain, we're going to look at our x values. I'm going to just put them in order. The set of numbers, we're going to do a roster. -2, oh, I'm sorry. Let's undo that. -1, 0, 2, and 5. So that is the set of x values. And then my range is going to be 2, 3, -4. I don't have to repeat -4. I can just say, in order, 2, oh, that's not in order. Oh, goodness. -4, 2, and 3. All right, so that is my set of y values. Is f a function? So we want to check and see, do our x values repeat? No, none of our x values repeat. If we graphed this, it would pass the vertical line test. So is this a function? Yes. And I'm going to say why? Well, none of the x values repeat. Now, we have to be careful. If I had something repeat itself like 2, -4, let's say that also was another ordered pair, they repeated themselves, but be careful because it actually is the same point, so it's not technically repeating itself. All right, find the inverse of f. So the inverse, we would take our x and y and switch them. So -1, 2 becomes 2, -1. 0, 3 becomes 3, 0. You get the picture. -4, 2, and -4, 5. All right, is the set of those points, and they have commas between. All right, now it says state the domain and range of g. So this is our new function, our inverse of f is g. So our domain is -4, 2, and 3. -4, 2, and 3. And our range is -1, 0, 2, and 5. Sorry, I'm not color coding this. Ooh, let's lock that. Let's make it purple. All right, so my range now is -1, 0, 2, and 5. Is g a function? So we want to look and see, do our x values repeat? Aha! We have -4 repeating with different outputs. So we can't have the same input with different outputs. So this is not a function. G is not a function. Why? Because the x values repeat. So if I was to graph that, I would end up with -4, 2, and -4, 5. It would fail the vertical line test because it would have two values of y for the x. This I just left. What is the relationship between the domain and range of f and the domain and range of g? And for f, the domain became the range for g, and the range became the domain. So the domain and range switched places. F and g are inverses. Predict the relationship between their graphs. If you verify your prediction, okay, by graphing f and g. So we plotted some points, and I know this is not all of the points, but this is one of the functions and this is the other. And if you notice, there is a symmetry. And the symmetry is about the line y equals x. It's a very important line when we're talking about inverses. And I like to see it as a butterfly. I mean, I want to check, I want to tilt my head and see, is there symmetry about that line? And in this case, there is. If two functions are symmetrical about the line y equals x, then they are inverses. All right, so let's talk about what are some of the steps in order to find an inverse. When a relation is represented by the equation like that, state the steps used to find the equation of its inverse. So inverse, we're taking x and y and we're switching them. So if I have a y here and an x here, I want to switch that. X equals negative 1/3 y plus 7. So that's my first step. Step 1, switch x and y. And step 2 is just, well, now get y by itself. Isolate y. So to get y by itself, I need to get rid of this plus 7 and this negative 1/3 multiplied. So I want to maybe subtract 7 first. So we end up with x minus 7 equals negative 1/3 y. At this point, you could do it in 2 steps. You could do it in 1 step. You could get rid of this whole chunk by multiplying by a negative, multiplying both sides by a negative and negative 3. Right? Because 3 times a third is going to be 1, and negative times negative gives a positive, so this ends up just being y, and that was our goal, to get y by itself. So we multiply this side by negative 3, and notice it goes to both terms in that binomial, so negative 3x plus 21. That would be the inverse of our initial function, and we'll talk about this in the next lesson, but we state inverse by going like this, y, and it looks like a negative 1 exponent, but we read that y inverse. Read inverse. You don't say to the negative 1 power. Okay, so the inverse of y is this. Oops, almost chopped off my negative 1. All right, so I'm going to give you a minute. I want you to try these. I want you to pause and then hit play and see if you got the same answers as me, if you haven't done this already. Okay, go ahead, hit pause. All right, so you should have gotten this. If you haven't finished trying them yet, pause or go back, try them, and then hit play again. This one has 2 possible answers. We're going to 2 different ways. You could have it as x over 5 equals y inverse, or 1/5 x equals y inverse. These are both the same thing. All right, if we're going to graph it, this might feel a little clearer that our slope is 1/5. All right, so on the next slide, it's going to ask us to graph these, to graph the equation and the inverse. So I need to take a picture really quickly of this and put it on the next page. Okay, so we are going to graph each of those functions and then graph the inverse function. If you want, you can hit pause and try this, but remember this is just slope, and y-intercept here is 0, so 0 is y-intercept, rise 5, run 1. So that's our slope. Go ahead, try graphing these 3. I'm going to hit pause, try graphing those, and then I'll come back to you. All right, hit pause. All right, so our original graphs should look like this. Then when we graph our inverse graphs, so now we're going to graph this one, and I'll use the same colors that I'm using down here. So I'm going to graph this pink one is the inverse graph. Okay, so our y-intercept again is 0, but now our slope is rise 1, run 5. Rise 1, run 5. All right, let's go over here. We've got an orange. Our y-intercept is 1/2. And our slope is rise 1, 1, 2. Rise 1, run 2. All right. last graph would be positive 9 is our y-intercept. Goodness, we're way off here. Okay, so 5, 6, 7, 8, 9 is our y-intercept. Whew. And then negative 3/2. So down, let's actually make a line here. 5, 6, 7, 8, 9. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. All right. Okay, so what we're going to see with all of these is we're going to see that they are symmetrical about that line. And what's that line? You should remember. What is it? What's the line that an inverse is symmetrical about? Y equals x. Yes, Rintaro, good. All right, so this line right here, y equals x, it should be symmetrical. This half, if you folded it onto this half, should be the same. So this is also symmetrical. I kind of have to tilt my head, angle it to the right so I can see that they match up. And this one as well. This one's a little harder to see, but it kind of looks like a dragonfly or something. All right, you see all my butterflies? Yay. All right, well, I think that's all for the inverse video. I'm sorry if it ended up being kind of long, but I hope that helped. Adam. All right, bye.